Ever wonder how data can reveal secrets about life expectancy, education, and urbanization, all in just 3 columns in a spreadsheet? Welcome to this Intro to Statistics session, where we're going to delve into variables, samples, populations, hypotheses. This is all in order to make your research more effective. Why should you trust me? My name is Bogdan Popescu, and I'm an assistant professor at John Cabot University of Rome. I also used to teach at Oxford and at Princeton. In my career, I taught many undergraduate and graduate students quantitative skills in order to produce their own research papers. Well, stick around and let's dive right in. Okay, so today we're covering some very basic statistical concepts like variables, samples, population, but also hypotheses. So, first of all, let us cover variables. So, how are two or more variables related? First, we have to make the distinction between an independent variable and a dependent variable. An independent variable is something that is thought to cause variation in another variable. The dependent variable is something that depends on or is caused by the variation in the independent variable. So typically, the independent variable has an impact on the dependent variable. So for example, we can think of education as having an impact on income. The more education people have, the richer they become. So two variables are associated if knowing the value of one variable will help us predict the value of another. So let us think, for example, about the relationship between life expectancy and urbanization. So urbanization is a measure for how urbanized or how urban different areas of the world are. So life expectancy, on the other hand, is an indicator for the overall well-being, physical and mental well-being of people, of citizens in a country. So this is clearly of interest to a lot of economists and a lot of researchers. And this is data that's covered by the UN, covering almost 214 countries. So let's imagine we're interested in understanding the extent to which the level of urbanization is connected to life expectancy. Entity and code are our units of analysis. So these are countries. And then we have these two variables, life expectancy and urbanization. We have a row for every country. So notice Afghanistan, that has a code AFG, has a life expectancy 45.38 and urbanization 18.61. Notice that these are actually averages. So this is averages that I computed myself, starting with historical life expectancy and urbanization data going as far back as the 1940s up to 2011. So that is why for some countries, maybe life expectancy will be unexpectedly low, but this is because it takes into account values prior to maybe even World War II. So the point here, this is a data set where every single row is one country. So in other situations, units could also be people, could be firms, could be survey respondents, and so on and so forth. So the variables are life expectancy and urbanization. These are the two columns that we have here. So these are the characteristics that vary among units. Okay, so the first question that we should be asking ourselves, what could be the factors that could be impacting life expectancy? Essentially, what are the characteristics of countries that have high life expectancy? What do they share in common? Similarly, what are the characteristics that countries with lower life expectancy have in common? So we can think of things like income, urbanization, and education. So urbanization is potentially just one of these many variables. So we have life expectancy here, some countries where you have longer life expectancies and some countries that have shorter life expectancies. Typically, countries where you have high life expectancy, those are countries that have higher incomes, where citizens are more educated, where there's more effective delivery of public services, and so on. Here's the relationship, the association between urbanization and life expectancy. So this is called a scatter plot, where every single point is one unit, one country that has two characteristics, urbanization and life expectancy. So it's important to distinguish between associations and causal relationships. So if two variables are associated, this means that if we know the value for one, we can help predict the value in the other. A middle-income country would have a longer life expectancy than a low-income country. Similarly, if we think about urbanization, a country with more urbanization would have longer life expectancy than a country with lower urbanization. A causal relationship is different from an association in the fact that it consists of three different elements. So one, the independent and the dependent variable covaries or are associated. So a causal relationship is first and foremost based on an association. So this means that when you see an increase in the independent variable x, you're also expected to see an increase or a decrease in the dependent variable y. What's really important, which makes this different from an association, is the fact that the change in x precedes the change in y. So this means that the change in x happens before the change in y. And then the other important criterion here is that the covariation is not coincidental or spurious. So causal relationships typically are stipulated in hypotheses. So what are hypotheses? Hypotheses are explicit statements about the relationship between phenomena that typically is a formulation of the researcher's guess. So good hypotheses typically are based on logical reasons or some hunch by researchers, and they also indicate the direction of the relationship. So data also has to be feasible to obtain in order to confirm or disconfirm the hypothesis. And typically, the units of analysis have to be specified clearly. Are we talking about countries? Are we talking about individuals? Are we talking about companies? And so on and so forth. So here are examples of good hypotheses. People have political views similar to their parents. Democracies are more likely to engage in trade with one another. Authoritarian regimes are more likely to violate human rights. Countries where property rights are protected tend to have higher levels of development. All of these are good hypotheses because they specify what the unit of analysis is, they have an independent and a dependent variable, and they have a direction of association. It's also important to have definitions of the concepts that we're using. So in the hypotheses that I just outlined, we have things like democracies, authoritarian regimes, political views, property rights. Before we get to test these hypotheses, it's important to define these concepts. These concepts have to be clear, accurate, precise, and informative. Okay, in terms of our units of analysis, so we have to make the distinction between populations and samples. Populations can be defined as the complete enumeration of some set of interest. But the problem is we rarely have access to the whole population. So that is why we're typically dealing with samples. Sampling is the process of subsetting from the population, selecting individuals from the population. So typically we want to take a random sample from the population in a way that allows us to have a group of people or observations that's reflective of the actual population. So this means that we have to know to some extent our population before we take this random sample. So the dominant approach here is probability sampling. So it's a statistical procedure that allows us to ensure that our sample matches to a great extent the characteristics of our population. So a representative sample is a group that, if repeated, the features of the sample would match the characteristics of the population on average. So the reason why probability sampling is an effective method is because this allows us to reduce sample selection bias, and it allows us to make sure that the group that we end up with is representative of the actual population. Moving on to data and variables. So it's important to distinguish between three types of categorical variables. So we can have binary variables. These are variables that have values like 0 or 1. For example, you can think of employed, unemployed, black and white, man, woman, and so on and so forth. Nominal variables. So these are kinds of categorical variables where order does not matter. So what is your favorite color? Red, blue, yellow. The order here does not matter. Nominal variables are different from ordinal variables. As the name suggests, for ordinal variables, the order matters. So to what extent are you satisfied with your government? You can be very satisfied, moderately satisfied, or unsatisfied. That clearly suggests an order to one's responses. We can also have numerical variables, such as discrete, such as the number of individuals in a household or number of students in a classroom. You can also have continuous variables. These are types of variables that have decimals. So things like height, weight, wages. Okay, moving on to cross-sectional data. This is actually a type of data that we started off with, like looking at life expectancy and urbanization. So the reason why this is called cross-sectional is because we have one single observation per unit. In our case, this was countries. A more technical way to write this, we have data for one variable measured in n units, so in our case, countries. So we would have something like this: x subscript 1, x subscript 2, all the way to x subscript n. This is also can be written as, it can be more efficiently written as this: x subscript y, where I is equal to 1 all the way to large n, uppercase n. So this is, for example, what this means in practice. Imagine that this is the variable that we're interested in. We have life expectancy and we have all these different values. So big X or uppercase X is life expectancy. This is the variable that we're concerned with. We have the first observation, X subscript 1, which is 45.38. We have the second observations, X2, which is 68.28. And we have the third all the way to the nth observations. So this is what this notation, how this notation here is reflected into the actual data. So here's once again spelled out. So x1 is equal to this number, x2 is equal to this number, and so on and so forth. Okay. So if we measure two attributes, so life expectancy was one attribute or one variable, but if we have a second variable, a second attribute, we can represent the units, the countries in our case, as a point in a 2D space. So essentially, this is a data point with two dimensions. Let's imagine that we have a unit that has life expectancy 59.75 and a level of urbanization of 66.4. So our data point is this: x is equal to this number, 66.4, which is the level of urbanization, and then 59.75, which is life expectancy. So this is how we reflect this. On the x-axis, we have urbanization. On the y-axis, we have life expectancy. This is this point that has a life expectancy of 59.75. Notice that this is very close to 60, but it's just a bit smaller than 60. And then we have urbanization, which is 66.4. So this is this point here that has life expectancy 59.75 and urbanization 66.4. So moving on to evaluating empirical propositions. So typically social scientists use empirical analyses or statistical analyses in order to test out these hypotheses. So hypotheses are fundamentally falsifiable claims about the world. So hypotheses have one dependent variable and one independent variables. So once again, the dependent variables are the ones that we're trying to explain. The independent variables are the type of factors that have an impact on the dependent variable. So all these hypotheses have to have these two elements. A good hypothesis typically starts off or sounds like this. An increase in X leads to an increase in Y. So this is, for example, the democratization hypothesis. More economic development is associated with higher levels of democracy. So we would typically test this hypothesis using data based for both X and Y. And this data should have some units of analysis, which are the entities where the theory applies. So far, we've seen countries as the main unit of analysis. So we collect this data and we have a spreadsheet or a tabular format of this data. So this is called the data set. Here you have on the y-axis the dependent variable as it's spelled out here. And on the x-axis, you have the independent variable. So in this case, we notice that there seems to be a positive relationship between x and y. So as x increases, so does y. But what is interesting here is that not all the high x observations have high y, but also not all the low x observations have low y. In order to evaluate this relationship, we're fitting a line that tries to best approximate the relationship between x and y. So this is, for example, what this looks like. This is the line that best approximates this relationship between x and y. If we have a third variable, so far or before we focused on life expectancy and urbanization, but imagine we also have education, we would move to a 3D environment. So initially we have a 2D environment where we have just two variables. Moving on to time series data. So a time series is typically written as t. So remember that before, instead of t, we had n. In this case, we have something like this, x1, x2, x3, all the way to xt, or this is equivalent to x subscript t, where t is everything from 1 all the way to t. So a time series is a sequence of data points indexed in time order. So this is, for example, what this would look like in the case of life expectancy. So rather than having a single observation, like the United States without any year, now we do have years. So we would have all the probably 120 years of observations for life expectancy. So this is X, so this is the variable life expectancy. So here we have X1, which is 49.30. So this is life expectancy in the United States in 1901. And this is the life expectancy in 1902, all the way to 2021, where life expectancy is 77.3. Notice the difference, once again, between time series data and cross-section. So here we have 1, 2, 3, all the way to t. This is the time series data. And here we have 1, 2, 3, all the way to n. So typically time series have their last element listed as t, while cross sections have typically the n listed as the last element. Okay, so we can still depict time series in a 2D format, but in this case we have time and value, right? So previously we only had a value because it was only one country without any reference to time. Now we also have a time reference. So this is, for example, life expectancy for the United States depicted in red, and this is life expectancy for Italy from 1901 all the way to 2021. So we notice here the dips around World War One and around World War Two, and we also notice that Italy is picking up around 1975 or so. What we have here for Italy and the United States is what is called a balanced panel. What does this mean? This means that every unit is observed in every time period, and we have no missing data point. This is different from this situation. Let us look at the case of Afghanistan that doesn't have data, or at least in the data set that I loaded in memory, there's no data prior to 1950s. So if we include this in our analysis, we would say that we're dealing with an unbalanced panel. This is because we have some missing data for some units. Another example of an unbalanced panel is this. So let's imagine we have Iran. So we have some interruption between, I guess, 1958 and 1975. So this is another example of an observation that will make our panel unbalanced. Okay, we have covered quite some ground today. It's important to note that measurement quality depends on accuracy and precision. We looked at different types of variables. The main types that we looked at are categorical and numerical. We looked at different types of data. So we can have cross-sectional data, we can have time series data, or both. So this is when we're dealing with panel data. Panel data can be balanced or unbalanced. So it's balanced when we have time units for all the observations, and it's unbalanced when we do not, when we have some missing time values for some observations. We also discussed hypotheses, like what good hypotheses are, what dependent and independent variables are, and how to make sure that our hypotheses always make a connection between a dependent and independent variable and always specify what the unit of analysis is. Thank you, and see you very soon. I hope you enjoyed this video. If you found it helpful, please give it a like and press subscribe. Also, if you have any questions or comments, feel free to leave a comment down below. Thank you, and see you in the next video.